Hi everyone, George here from Data Academy. Today let's talk about cross-validation. So cross-validation is basically a robust way to help you to evaluate your machine learning model's performance. Why robust? Well, two reasons. Number one is more stable. Think about it. If you test your model multiple times, chances are each time it's going to be a little different. However, if you take an average of the different results across different runs, then you are going to get a more stable result. And secondly, the specific patterns in your data may give you a bias in the result. Think about it, maybe this specific split of your data is particularly easy for your model to handle. And with another split, maybe you are going to get a different result. So cross-validation helps you to tackle both kind of situations. So for example, if we look at this image here, if we're going to split our data into 5 folds, fold 1 through 5, and each time we can basically train the model on 4 folds, and we can test the model on the remaining 1 fold. So with the split number 1, we're going to train the model on fold 2, 3, 4, 5, and we are going to test the model on fold 1. And on split number 2, we are going to train the model on fold 1, 3, 4, 5, and we are going to test the model on fold 2, and so on and so forth. And at the end, you are going to get 5 different accuracy results, and then you can take an average. And that is going to be your cross-validated, 5-fold cross-validated accuracy result. So that's basically what cross-validation is. Now, let's walk through the process of doing cross-validation. So first, we're going to import all the libraries as usual. And then we're going to load the data. Now, let's look at the process to do the cross-validation manually first. So we're going to use the k-fold class from Scikit-learn to create the folds. So in this case here, we're going to say we want 10 different folds or 10 splits, and we're going to instantiate the k-fold this way. Also, we're going to create a scores list to store all the different testing scores. Now we're going to loop through all the different splits of the data by doing this. And next, each time we are going to create the training and the testing features like this, and the training and test labels like that. And every time we want to use the same model, so we're going to recreate the model each time like this. And now we are going to train the model using the training data, i.e. the 9 folds. And then we're going to test the model using the remaining 1 fold. And finally, we're going to report the score and store that score in the scores list. Now let's do this and see what the result is. Okay, there you go. So now you see you're going to get different accuracy result each and every time, right? However, if you take an average, you get this 94%. That's the average accuracy. So basically, this is your 10-fold cross-validated accuracy result. So that's how you do it using the manual process. So let's see how to do this using an automatic process. Okay, so we're going to use basically the cross-val score function from Scikit-learn. So we're going to instantiate the random forest classifier, and we're going to use the cross-val score this way by saying, I'm going to provide you with the classifier, and here is the features, and this is the labels, and I'd like to do a 10-fold cross-validation. So now if we do that, we can see the result. So there you go. You see each and every time we also get a different accuracy result. However, when you take the average, you get exactly the same result as last time. So that's the point. When you do 10-fold cross-validation or 5-fold cross-validation, it's going to give you a more stable, representation of your model's performance. And that's why we want to do cross-validation. So that's it. Thank you so much for watching. And next time we're going to talk about automatic machine learning. Stay tuned.